Why does the umpire consider tossing a coin a fair way of deciding which team gets to bat first in the cricket match? At the end of this lesson, you should be able to define the terms experiment, outcome, event, and probability. Compute the probability of an event by applying the formula of theoretical probability. Study the probability of events of simple experiments through interactive games. Compare the results of experimental and theoretical probability. Krish and Harry are watching a cricket match on the television. Let us listen to their conversation. Krish, it is likely to rain today. Harry, yes, it may rain today. Krish, India has a great chance of winning the cricket match. Harry, there is a possibility of India winning the match today. Krish, Tendulkar may score a century today. Harry, I doubt whether Tendulkar will even stay at the wickets with Muralidharan having 6 overs to bowl. In the conversation between Krish and Harry, you heard them use certain phrases and words. What do the words likely, may, chance, doubt, and possibility have in common? The words such as likely, chance, and maybe, which we use in everyday life, involve an element of uncertainty. That is, there is uncertainty about the happening of the event in the question. In the real world, events cannot be predicted with 100% certainty. The uncertainty of these words is measured numerically by means of probability. Therefore, the study of chance or likelihood of an event happening is called probability. Now, take a look at another situation. Krish is experimenting with tossing a coin. The possible outcomes of the experiment are the coin can land only in 2 possible ways, either head up or tail up. We know that an experiment is a situation which involves a chance of certain result occurring. Here, tossing a coin is an experiment which has 2 possible outcomes, namely a head or a tail. So, an outcome is the result of a single trial of an experiment. A chance of getting a head or a tail is an event. So, an event is one or more outcomes of an experiment. The probability of getting a tail or a head in a single trial is 50%. Therefore, probability is the measure of how likely an event is to occur. What do you conclude from this? Probability of events which are based on the results of actual experiments are called experimental or empirical probability. It is given by the ratio of number of times the event occurs to the number of trials. Can we predict whether the next satellite's launch will be successful using probability? The empirical interpretation of probability can be applied to every event associated with an experiment, such as rolling a die or tossing the coin, which can be repeated a large number of times. How can we represent the experiment, such as launching a satellite to test its success? Requirement of repeating an experiment has some limitations. It is not feasible in many situations and is very expensive. In experiments where we are prepared to make certain assumptions, the repetition of an experiment can be avoided, as the assumptions help in directly calculating the exact theoretical probability. The assumption of equally likely outcomes is one such assumption that leads us to the following definition of probability of an event. The theoretical probability, also called classical probability of an event, E, written as P of E, is defined as the ratio of the number of outcomes favorable to E to the number of possible outcomes of the experiment where we assume that the number of outcomes are equally likely. There are 2 ways of determining probability. One is by performing an actual experiment and the other is by calculating it theoretically. We know that theoretical probability is determining by analyzing the possible outcomes theoretically, whereas experimental probability refers to the probability of an event occurring when an experiment was conducted. As we repeat the experiment a number of times, The results of experimental probability will get closer to the theoretical probability. Now, let us compute the theoretical probability of tossing a coin. In the experiment of tossing a coin once, there can be two possible outcomes, a head, H, and a tail, T. Let E be the event for getting a head. The number of outcomes favorable to E, that is, getting a head, is 1. We know probability P of E is the ratio of number of outcomes favorable to E to the number of all possible outcomes. Therefore, P of E is equal to P of head, that is equal to number of outcomes favorable to E divided by number of all possible outcomes, that is equal to 1 by 2. Similarly, if F is the event getting a tail, then P of F is equal to P of tail, that is equal to 1 by 2. In tossing a coin, we can assume that each outcome, head or tail, are as likely to occur as the other, and hence the event has equally likely outcomes. Now, observe the tossing of a coin before the start of the game of cricket. Here are the captains of the two teams and the umpire in the cricket ground. Do you know why and how a coin is tossed in the game of cricket? In the game of cricket, a coin is tossed to determine which team bats first. This is known as the toss. The captain of the two teams call heads or tails. During coin flipping, the coin is tossed into the air such that it rotates over and over several times. Depending on custom, the coin may be caught, and inverted or allowed to land on the ground. When the coin comes to rest, the toss is complete and the party who was assigned the face up side is declared the winner. Tossing a coin is considered a fair way of making decision in sports and also several disputes because the coin is symmetrical and there is no reason for it to fall on one side more than the other. This property of the coin is called unbiased, and in a random toss, the coin is allowed to fall freely without any bias or interference. Now, observe the outcomes of tossing the dice. From the above activity, we learned that in the experiment of rolling a dice, the number of possible outcomes is 6. When a single die is thrown, there are 6 possible outcomes: 1, 2, 3, 4, 5, 6. Here, the number of favorable outcomes is 1, and the probability of getting any one of these numbers is equal to the probability of an event P of A, which is equal to 1 by 6. What do you conclude from this? The possibility of getting any of the numbers on the dice is equal, and therefore rolling a dice can yield equally likely outcomes. Let us solve a spinning problem. A spinner has 5 sectors: color yellow, blue, green, and orange. What are the chances of the spinner stopping at A. Orange, B. Green? What is probability of an event? We know probability of an event PE is the ratio of number of outcomes favorable to an event to the number of all possible outcomes of the experiment. Here, the number of all possible outcomes of the experiment is equal to 5. Number of favorable outcomes when the spinner stops at orange. Number of favorable outcomes when the spinner stops at green. Substituting the values and simplifying, we get probability of spinner landing at orange, P orange, is equal to 2 over 5, and the probability of spinner landing at green, P green, is equal to 1 over 5. Ooh! Here is a fruity problem to determine the probability of picking a fruit from a basket. A fruit basket contains 5 oranges, 5 apples, and 10 bananas. YB picks up a fruit randomly from the basket without looking at it. What is the probability of him picking A. An apple, B. An orange, C. A banana. What is probability of an event? Probability of an event, PE, is the ratio of number of outcomes favorable to an event to the number of all possible outcomes of the experiment. Here, the number of all possible outcomes of the experiment is equal to 20. Substituting the known values and simplifying, we get probability of picking up an apple, P apple, is equal to 5 by 20, that is equal to 1 by 4. Probability of picking an orange is 5 by 20, which is equal to 1 by 4 again. And the probability of picking a banana is equal to 10 by 20, that is equal to half. Therefore, probability of picking an apple is 1 by 4. Probability of picking up an orange is 1 by 4, and the probability of picking up a banana is 1 by 2. Two coins are tossed simultaneously. Find the probability of getting A. 2 heads, B. 1 head, C. At least 1 head, D. Not more than 1 head, and E. No head. What is probability of an event? We know that probability of an event, PE, is the ratio of number of outcomes favorable to an event to the number of all possible outcomes of the experiment. On tossing the two coins, the outcomes possible are HH, TT, HT, TH. So, the number of all possible outcomes of the experiment is equal to 4. And the number of favorable events for getting 2 heads is equal to 1. Therefore, probability of getting 2 head, P 2 head, is equal to 1 by 4. The number of favorable events for getting 1 head, that is equal to HT, TH, is equal to 2. Therefore, probability of getting 1 head, P 1 head, is equal to 2 by 4, which is equal to half. The number of favorable events for getting at least 1 head, that is HT, TH, HH, is equal to 3. Therefore, probability of getting at least 1 head is equal to P 1 head, that is equal to 3 by 4. The number of favorable events for getting at most 1 head, that is HT, TH, HH, is equal to 3. Therefore, probability of getting at most 1 head is equal to P at most 1 head, that is equal to 3 by 4. Number of favorable events for getting no head, that is TT, is equal to 1. Therefore, probability of getting no head is equal to P no head, that is equal to 1 by 4. Did you know how the maths of probability started? Gambling has been popular since a very long time. As the games became more complicated and the stakes became larger, there was a need for mathematical methods for computing chances. In 17th century, a well-known gambler, the Chevalier de Mere, consulted Blaise Pascal in Paris to find information about some games of chance. Pascal began to correspond with his friend Pierre Fermat about these problems. The correspondence between Pascal and Fermat is the origin of the mathematical study of probability. Did you know that the concept of chance rules in everyday life? Every time you decide to eat something, there is a probability that you may fall sick, and every time you plan to travel, there is a probability that the train may be delayed or the flight may be rescheduled. If you choose a particular day to go out for a picnic, you make plans based on the weather forecast. Our daily life is full of decisional situations. We apply the concept of probability so frequently without realizing it. Probability theory is used extensively in various areas of study as mathematics, statistics, finance, science, artificial intelligence, and philosophy.